This is lesson 11.1, the law of sines. Our objectives for today are to use the law of sines to find missing parts of a triangle and solve real-world problems using the law of sines. So the law of sines has to do with triangles, as we saw in the objectives. And specifically, it has to do with non-right triangles. We already know how to solve for the sides of a right triangle. You can use a squared plus b squared equals c squared, Pythagorean theorem. And we've also learned SOHCAHTOA that you can use. But what if you don't have right triangles? That's what the law of sines and our next lesson, the law of cosines, are for. But before you can use the law of sines and cosines, it's really important to know how to label the sides and angles of a triangle. The way you label them makes a difference because to use the formulas, you have to have them set up and labeled correctly. So we have triangle ABC, and it actually doesn't matter what corner you start with, right? So A, B, C. So what matters is we label the sides across with small letters, right? So the side across from the big A has to be little a. Side across from big B has to be little b, and the side across from big C has to be little c. If you don't set it up this way, then your equations and formulas won't work for law of sines and cosines. So this is important. All right. So what is the law of sines? It states that the ratio of the sine of each angle in a triangle to its opposite side is constant. It's like, what does that mean, right? So basically, if you have a triangle, and we'll label it here, A, B, C. What it says is the ratio, that's a fraction of the sine of each angle in a triangle to its opposite side is constant. That means that sine of A over A is the same as sine B over B, which is the same as sine C over C. It means that we can set up proportions with the sine of each angle and its opposite side in order to solve for things that we have missing. So let's try this one. Okay, so if you look at this triangle, when you're using the law of sines, you're always looking for angles across from sides, and that's what you set up, right? So right here I see that 93 is across from 10, so we can write sine of 93 over 10. Now I'm looking for that x. It's across from the angle 48, so we can write sine of 48 across from x. And now we've made a proportion. All right, so you write the angle across from its side. Okay, so you can see why setting it up is important. It has to be each side goes with the angle across from it. All right, so now what we need to do to solve a proportion is cross multiply, right? Cross multiply. So x times sine of 93 equals 10 times sine of 48. And then we would just divide by the sine of 93 to solve for x. Okay, so x equals 10 sine 48 over sine 93. So now what we have to do is type this into a calculator. So let's try that. Look at this calculator over here, and I'm going to type it in. So 10 sine 48, and we'll close our parentheses, divided by sine of 93. All right, and there's our value right there. Also, it's important, make sure you're in degrees mode for all of this, because these are in degrees. So x equals 7.4, rounding to the nearest tenth. Okay, let's try another one. So use the law of sines, find the measure of x. So this time we're missing an angle. All right, so look for an angle and a side across from each other. I see 96 across from 18. So sine of the angle across from the side. Sine always goes with the angle, right? And so then this one's going to be sine of x over 10. So again, cross multiply. 10 sine 96 equals 18 sine of x. All right, now this is funny. The x is stuck inside this sine, okay? We can divide off the 18. And now we have this, but this is equal to the sine of x, right? It's equal to the sine of x. It's not equal to x. So let's type what we've got so far in our calculator, and then we'll talk about how to get x out of that sine. All right, so 10 sine 96. I discovered that you don't actually need the first set of parentheses. See, look, it automatically divides it correctly. See how it's all over the 18, so it's fine. All right, so what we've got now is the sine of x. So in here, we're going to go to functions, and we're going to do the sine inverse. To undo a sine, you do a sine inverse. And I'm just going to pop that answer in there. Okay, so now we have our angle measure. We got rid of the sine, and what's left is our angle measure, 33.5 degrees. Okay? All right, next, the sides of a triangle are 15, 17, and 16 inches. The smallest angle has a measure of 54. Find the measure of the largest angle. So if you're not given a picture, the easiest way to do these is to make a picture. So 15, 17, 16. Okay, now the smallest angle has a measure of 54. How do you know which one is the smallest angle? So in triangles, it turns out that the smallest angle will always be across from the smallest side. The biggest angle will always be across from the biggest side. If you think about this, right? If you have an angle and you make it wider, right? A wider angle has a longer space, right? Bigger angle means bigger side across from it. Okay? So our smallest angle, 54, is across from our smallest side, 15, which means the biggest angle that we're trying to find is across from the biggest side, 17. So let's set this up. Sine of 54 across from 15 is equal to sine of our largest angle across from our largest side. All right, so let's cross multiply now. So 17 sine 54 equals 15 sine x. And remember, the x is stuck inside the sine, so you can divide off the 15. And then to get the x out of the sine, again, we're going to have to use the sine inverse of the answer that we get in order to get the angle. So let's do that on the calculator. I'll show you again. All right, so I'm going to type 17 sine 54. Remember, degrees mode for all of this. Oops, close the parentheses. Okay, divided by 15. Okay, so that's our sine of x. So to get x out of the sine, we now need to do the sine inverse in functions, sine inverse, and then just click answer to pop in the answer. And there we see it, 66.5 degrees. Okay? All right, next one. The measure of angle A is 67, angle C is 100, little b is 12.4, find C. So draw your triangle, label A, B, C. So A is 67, C is 100, little b, that'll be across from big B, is 12.4. Find little c, that's across from big C. All right, so look for things across from each other. I have angle 100 across from C that I'm looking for. And now here's a problem. Angle 67 is not across from a known side. And the 12.4 is not across from a known angle. So we need two things that are across from each other that we know. So this is a problem. But remember, in a triangle, the three angles add to 180, right? So I know two of the angles, so if I subtract off those two angles that I know from 180, I will know that angle B is 13 degrees. And now I can set up sine of angle B with side B. Okay? We can cross multiply. So 12.5 sine of 100 equals C times sine of 13. So we're solving for C. We can divide off this sine 13. Right? And that will give us C. So let's try this on the calculator. Okay. So 12.5 oops, 12.4. It's 12.4 and I wrote 12.5 over here. I'm sorry. Sine of 100 over sine 13. Okay, so that's our value for C. Okay, so 54.3. Okay, yeah, this should have been a 12.4. Sorry, guys. Okay, it's 12.4. 12.4. All right, next one. In triangle SUN, little n is 4, little s is 7, and angle S is 112. What is the measure of angle U? So, draw it. Always draw. SUN. So little n is 4, little s is 7, angle S is 112. What is U? Okay, so I noticed that I have 112 across from 7, so we can use that. All right, now look, I'm trying to look for angle U, but I don't have a side for little u. I have a side for angle N. So what we're going to have to do is we're actually going to have to solve for angle N instead of angle U, because that's the value that I have. And then we'll have to use the fact that the three angles of a triangle add to 180. We could subtract off the 112, and then once we get the value of N, we can subtract off the value of N. All right, so 4 sine 112 equals 7 sine of N. Remember, sine of N. N is stuck inside that sine, so we'll divide off the 7. And then we're going to have to use the sine inverse to get the N out of that sine. Okay, so let's try this on the calculator. So 4 sine 112. I hope you're doing this on your own calculator, so you're not trying this on your own for the first time on your homework. Okay, and so remember, this is the sine of the angle, so now to get the angle out of the sine, we're going to use the sine inverse to cancel out the sine. Pop in the answer. Okay, and then we have to do 180, right? So that gave us angle N, but we need angle U, so we're going to use the fact that all three angles add to 180 and subtract off our 112, and now subtract off, just pop in the answer. All right, so angle U is 36.0. Okay. All right, next one. Find the measure of angle F if G equals 4.1. So let's label. They gave us a picture, but let's label. So I'm going to put an X for what we're trying to find, and I'm going to put a 4.1, right? Label your picture so you can see what you've got. Okay, so I've got 121 across from 4.1, and I'm trying to find F, and I have that across from 2. Okay, so 2 sine 121 equals 4.1 sine x. X is stuck inside the sine, so we can divide off the 4.1. And then to get the x out of the sine, we'll have to use the sine inverse. Okay, so let's do it on the calculator. So 2, oh, we don't need to put the times. The times kind of messes it up. 2 sine 121 divided by 4.1. So that's our value for the sine of x. So to get it out of the sine, I'm going to go in here and do the sine inverse of the answer. And there we go. Okay, so it is 24.7 degrees. Okay, solve each triangle ABC if possible, round to the nearest hundredth. So solve the triangle means you have to find everything that's missing. Okay, so if you see solve the triangle, it means find all missing values. Okay, so if we draw a triangle, A, B, C, they've given us angle A is 40 degrees, little c is 20, little a is 50. So we need to find everything missing. We need to know how big is angle B, how big is angle C, and how big is side B, okay? So we're looking for everything missing. Okay, so let's try this. So the first thing I'm going to look for is things across from each other. So I have 40 degrees across from 50. So sine of 40 degrees across from 50. Now what else have I got? I've got that 20, and that's across from angle C, which we don't know. So let's cross multiply. So 20 sine 40 equals 50 sine C. Divide off the 50, and then we'll have to do the sine inverse. But I haven't put the calculator up because I feel like you've seen that enough. So I'm just going to type it in my own calculator. 20 sine 40 divided by 50, and I get a decimal, right? And then I'm going to type in the sine inverse of that decimal, right? Type it in on your own calculator and make sure you get the same answer that I do. So this was angle C, so I get that C is 14. This time it says round to the nearest hundredth. Okay, so if I round to the hundredth, I get 14.90, and that's degrees. All right, so 14.90. I like to label it on my picture so I can clearly see, or else at least always write out what you're trying to solve for, right? Write angle B equals angle C equals B equals, so you don't accidentally miss something that you were supposed to solve for. All right, I'm going to erase this to make room. Okay, so let's solve for the next part. So now in my picture, I notice that I have 2 of the 3 angles, right? So I can now do 180 and subtract off 40 and subtract off the angle that we just got, and that will give me my angle B. So on my calculator, I'm going to type 180 minus 40 minus 14.9. Okay, and I get 125.10. Okay, and then the last thing we're missing is side little b, okay? So we just barely solved for the angle big B, so now we have something across from little b that we can set up our law of sines. So I'll set up sine 40 over 50, and that's going to be sine of that B angle that we just solved for over our unknown side little b. So cross multiply, 50 sine 125.1 equals B sine 40, and then to solve for B, we can divide off the sine 40. Okay, so I'm going to go ahead and type this in my calculator. Try typing it in yours. 50 sine of 125.1, and then divide it by the sine of 40. Okay, and I get 63.64. Okay. All right, let's try this next one. Okay, so always draw your picture. So this time B is 20 degrees, little b is 4, little c is 12. So what are we missing? We're missing angle A, angle C, and side little a. Okay, always write yourself a note like this so you know what it is that you're trying to solve for. All right, so look for things across from each other. So I have 20 across from 4. All right, and then I've got a 12, and I can put that across from sine C. So 12 sine 20 equals 4 sine C. The C is stuck inside that sine. So we're going to do this and then do the sine inverse, right? So I'm going to type it in my own calculator. Try typing it in yours along with me. 12 sine 20 divided by 4. Okay, so I got a decimal, 1.02. And now I'm going to do the sine inverse of that decimal. Okay, when I typed this in, I got undefined. It said undefined. If this happens, what it means is you actually weren't given a good amount of information to be able to tell how big this triangle is, okay? We can't tell. So you have to write not enough information. There's sometimes when the information you're given, it's like ambiguous. So if you like did this in real life and you use your protractor and made a 20-degree angle and a side that was 12 long and a side that was 4 long coming off of here, it wouldn't, you might be able to make more than one triangle with this, if that makes sense. So you're not given enough information to make a triangle. So that happens. That's why it says right here, if possible. Okay? Sometimes the setup of the triangle makes it not possible. All right, let's try another one. Okay, so A, B, C. So C is 55, A is 27, little a is 9. So we're missing angle B, we're missing side little c, and we're missing side little b. Okay. So the easiest thing, we have two angles. Anytime you have two angles, it's really easy to figure out the third one, right? 180 and subtract off the other two. So I'm going to go ahead and type that in my calculator. 180 minus 27 minus 55 gives me 98. So our missing angle B is 98. Okay. Don't forget degrees, and we're in degrees. All right, now let's solve for the sides. So look for things across from each other. I know 27 across from 9. So we know both other angles, so you just pick, right? So let's solve for little c. So angle C across from little c. Okay, so if I cross multiply, I get 9 sine 55 equals c sine 27 to solve for c. Divide off your sine. Okay, so I'm going to go ahead and type this. So 9 sine 55, and then divide it by the sine of 27. Okay, so I got 16.24. Okay, and then let's erase this so I have more room. So now we can solve for little b the same way. Okay, so let's do the sine 27 over 9 again, and this time we're going to do b. So sine of angle b over unknown side b. So cross multiply, and we get 9 sine 98 equals b sine 27. Divide off the sine 27 to get the b by itself. So I'm going to go in my calculator and type 9 sine 98 divided by sine of 27. And I see that b is 19.63. So here's a note, okay? So remember how in an earlier problem we talked about the smallest side is across from the smallest angle and the biggest side is across from the biggest angle. So you can kind of check your work. Make sure it makes sense. Like my biggest angle here is B 98. It should be across from the biggest side, and it is, right? The smallest angle is 27. It should be across from the smallest side, and it is, right? So your answers should make sense in that way. All right, last problem. So in this problem, we're given angle B is equal to 29, angle C is equal to 141. We don't know angle A, we don't know side A, we don't know side B, we don't know side C. Angle A we could figure out. If you know the two angles, you know all three. Subtract from 180, right? So I'm going to do 180 minus 141 minus 29. Okay, and I get 10. All right, now here is a problem. We don't know anything across from anything else. We don't know any sides. And in fact, you can't solve the rest of this. All right. So you know from like previous math courses when you would do similar triangles, you can have a triangle with the same angles, but one is bigger and one is smaller. They're similar triangles, right? And so that's what happens here. Just because you know the angle measures, you don't know anything about the side measures unless you have one. You have to have at least one side measure or you don't have enough information to solve it, right? So remember, we did this, if possible. There's going to be some times when you can't actually solve it, if possible. All right, so that's this. Try your homework now. Send me pictures of your in-class and your homework, and send me questions if you have any questions through email or through the Remind app, or log on to my Zoom office hours. Thanks, you guys.